Hello, guys. Back to Maison African Motives. Still working on mathematics and two. In this case, we've got the question paper which was written March 2023 that we are going to work on as our revision so that we can see how we are supposed to attempt these typical questions. So without wasting much of our time, let us quickly rush through the questions that we are given. The first question, which is our question one, we are given to solve for h in each of the following equations. So we are given the first equation in terms of h, also the second equation in terms of h, and we are asked to round off the answer to 3 decimal places, that is for the second one. Okay, so let's see what we are given. I just hope with this space here we can have our question. So this is 1.11. So if we are to take, so we are given, that's 7 plus 7 into h minus 7. That was equal to minus 3 into h plus 7, like this. Okay, so if we can check here, we've got brackets, so we can expand brackets first, then we can collect our like terms. So that's 7. Plus 7 is going to affect the bracket. So that's plus 7 times h, which is 7h, plus 7 times a minus 7. This is going to give us a minus 49, okay, which is equal to, on the other side of the equation also, we have got negative 3 that is supposed to expand the bracket. So it's negative 3 times h, which is negative 3h, negative 3 times a plus 7, that is going to give us a negative 21 in this case. All right, so collecting the terms on the left-hand side, we've got 7 and minus 49 in this case. So 7 minus 49, that's minus 42 plus 7h, which is equal to, on the right-hand side, we've got minus 3h minus 21. So you can collect your like terms in this case, minus 3h to the right-hand side, to the left-hand side, sorry, then the minus 42 to the right-hand side, just like that. All right, so this is going to be 7h plus 3h, which is equal to, already we've got negative 21 on the right-hand side. So if we transpose the negative 42, it is going to be a plus 42 in this case. So that's 7 plus 3, which is 10h, is equal to minus 21 plus 42, which is going to give us positive 21. So dividing by 10 both sides so that we can remain with h. That was going to give us the value for h in this case, which is 21 over 10, or it can be 2,1 in this case. So as a decimal, it can be 2,1, or as a fraction, 21 over 10, like that. All right, so that was question 1.11. As you can see, guys, these were the stages that we're supposed to take. On 1.12, we are now given 3h squared plus 3h is equal to 7, and to 3 decimal place, that's a quadratic equation that we are given in this case. All right, so that's 1.12. We are given that 3h squared plus 3h is equivalent to 7. So first we can transpose, since we know that our equation is supposed to be in the format of ax squared plus bx plus c is equal to 0, like this. So meaning to say one of the sides must be equal to 0 so that we can apply our quadratic formula. So that's 3h squared plus 3h transpose 7 to the other side of the equation. That's minus 7 because it was a plus. So we know from our quadratic formula, we can solve for h. Since we are given to round off your answers to 3 decimal places, it's a definite issue that you are supposed to be using your quadratic formula in this case. All right, so that's our h is equivalent to minus b plus or minus the square root of b squared minus 4ac, everything over 2a in this case. So we are still having the same quadratic formula, but just h is equal to, because it's an equation in terms of h. So our a, which is the coefficient of h squared, which is 3, our b, which is the coefficient of h in this case, which is positive 3 again, c, which is our constant, that's negative 7, according to this equation that we are given, ax squared plus bx plus c. So a is the coefficient of x squared, b, the coefficient of x, c is the constant. So that means we can substitute our values minus b, which is minus 3, plus or minus the square root of b squared, that's 3 squared, minus 4 times a, which is 3, so that's times 3, times our c, in this case, which is a negative 7. So everything was going to be 2 times a. So 2 times a, which is 2 times 3. That's our a in this case. So that means we can simplify everything. In this case, I'm going to simplify this part only under the square root, this part only here under the square root, so that we know what is that value that is under the square root. So that value is going to give us a 93. So that is going to be the square root of 93. 2 times 3, which is a 6. So if you are now to solve, you can separate these two. Since we've got a plus and we've got a minus, so that means one of the values is going to be under a plus sign, then one of the values is going to be under a minus sign. All right. So under a plus sign, the answer for h is going to give us negative 1,107, or for a negative value, our h is going to be minus 2,107. That is to 3 decimal places as per given instruction, that our answer is supposed to be to 3 decimal places. So the all is on the application, was on the application of the quadratic formula in this case, using your quadratic formula, but first rearranging your equation. That was the most important part that you were given in this case. All right. All right, so let's check the other part of the question, which is question 1.2. So we are now given the formula for 2 over d, which is equal to x squared over 4d. And from this one, we are asked to make d the subject of the formula. That is to transpose for d in this case. All right, so let's check what we are given in this case. That was question 1.2. So we can just remove this part so that we can have our question. All right, so we are given in this case, that's 1.21, that 2 over d is equivalent to x squared over 4d plus h. All right, so that was the normal equation that we're given in this case. So from this equation, what we can do is to have our h as a normal fraction h over 1, so that we can check the LCM or the LCD of the denominators, which is d, 4d, and 1. So our LCM or the LCD is going to be 4d. So we are going to multiply each and every term by 4d. We multiply this term by the LCM, which is 4d, also this part by 4d. All right. So by multiplying by 4d, d and d, this case will cancel. So that means you remain with 2 times 4, which is 8, is equal to 4d, and 4d will cancel. You remain with x squared. So h times 4d, that is going to be 4dh, okay, or 4hd, depending with the way that you want to express your answer. So remember that we are supposed to make d the subject in this case. So we can transpose x squared to the left-hand side so that it can be a negative, which is equal to 4dh. So in this case, we are remaining with 4 and h, which is affecting this d, the letter, to be the subject. So we can divide by 4h, since we are multiplying 4 and h, they are multiplying to d. So if we divide, we are canceling this. So that means our d is going to be equivalent to 8 minus x squared over 4h. All right, so that was going to be an expression, or the our d as the subject of the formula. All right, so that was question 1.21. It was a direct question. On 1.22, we are now given now to calculate the exact value of d if x is equal to 4 and h is equal to 2. All right, so here is just a matter of substitution. Already we have made our d the subject here. D is the subject. So on 1.12, that is 1.22, sorry. So our d is going to be equal to, in place of x, we are supposed to substitute our x. Remember that we are given that x is 4, while h is equal to 2. So in place of x, we substitute 4. In place of h, you substitute 2. So this is going to be 8 minus 4 to the power of 2, or 4 to the exponent of 2, everything over 4h, that is 4 times the value of h, which is 2. All right, so that's you guys and your calculator. This was going to give us a -1 in this case. All right, so that was the exact value of D. On the other part, we are now given that on 1.3, plane A flying from Lesotho to South Africa collided with the plane B flying from Swaziland to South Africa. All right, so we've got two planes that we have in this case. Given that the flight path of plane A is defined by the equation 4y minus 4t is equal to 4, and the flight path of plane B is defined by the equation, so this is the equation for plane B. Calculate the coordinates of the point of collision of plane A and plane B. Okay, if we are to check here, these are two equations that we are given, linear equations. So when these two, they collide, if you are to check, this is moving in a straight line. The other one is moving in a straight line. So when these two collide, they collide at a certain point, which is called the point of intersection. So what the question was just asking us in this case was to calculate the point of intersection for these two equations that we are given. And how do you determine the point of intersection? You determine the point of intersection by solving the equations simultaneously. So that was just the question, to just solve these two equations simultaneously. So I'm going to write the equations down. We are given the first equation in this case, which is 4y minus 4t is equal to 4. So that is going to be your first equation. Then the second equation in this case is given as 8t minus 22, which is equal to minus 2y in this case. All right, so this is our second equation. So from first equation, we can even reduce our equation so that we can solve this properly. So if you reduce this by 4, by 4, by 4, this is going to be y minus t, which is equal to 1. All right, so that's y minus t, which is equal to 1, of which you can even make y the subject to say y is equal to, if I transpose minus t to the other side of the equation, that's going to be a plus t. So it's going to be 1 plus t. So this is what I'm going to obtain from equation 1. All right, from equation 2, we can do the same again. To make y the subject, we can just divide by -2, since this is -2y. So we can divide by the coefficient of y, which is -2. So 8 divided by -2, this is going to give us -40. Negative cancels, 2 into 22, that's plus 11. Then we can divide here by -2, that is going to be a positive y. So meaning to say, we have another equation for y from our equation 2. So solving our equations, we can see that if these two are the same, this is y, also this is y. So these two must be equal. So it simply means that 1 plus t must be equal to minus 4t plus 11, the value of y that we have on the other equation. So this must be equal to minus 4t plus 11. So solving these equations, you can choose any method, substitution method, elimination, whatever method that you are suitable with, or that you are used to. All right, so equating these two, that means I can determine the value of t from this one. All right, so collecting the terms of t to one side of the equation, minus 4t is going to be a plus 4t. So that's t plus 4t, which is equal to transpose 1 to the other side of the equation, it is going to be a -1. So that's 11 minus 1. So t is same as 1t. So 1 plus 4, that is going to be 5t, is equal to 10. Divide by 5 both sides. So your t was going to be a 2 in this case. So that is t is representing the time x from the time axis. All right, so to find the value of y, you can substitute into any one of these equations, because here we are given y as the subject, also here y as the subject. So taking the first equation, which is y is equal to 1 plus t, we can determine the value of y from there. So y is equal to 1 plus t, and our t is 2. So that's y is equal to 1 plus 2. That means y is going to give us a 3. Okay, so that is what you're going to have. So what happens is that this is on a plane where the time is on the x-axis. So this is your time axis, and this is your y-axis. So when you are now talking about the point of collision, it was supposed to be x as a point of xy like this, but our x now is represented by t, which is the time. So that means in place of x now, we are going to represent with 2. So therefore, the point of collision is going to be 2. That is our t, and the value of y, which is 3. So these two, they collided at a point 2, 3. All right, so that was the condition of the question. In this case, to determine the point of collision, or you can even just write the value of y and the value of t, just to write these values only. Still it's fine like that, or you can even express it as a point. All right, so that was our question 1.3, having a total of 4 marks in this case. All right, so that's question 1, 14 marks. All right, question 2, we are now given the following algebraic expressions. All right, so these are the 2 algebraic expressions that we are given. Factorize each expression completely. All right, so from these 2 expressions, we're asked to factorize completely. All right, so let's check with the space that we have if we can factorize on this space here. So from the first equation, we are given 3ay minus 2by minus 3ax plus 2xb like this. All right, so these are 4 terms whereby we can factorize only by grouping these terms into 2. So if we are to check here, for the first 2 terms, do we have common factors? So let's check what we have here. Y is the only common factor, so that means we can factor out y. That's 3ay divided by y. We are going to remain with 3a minus 2by divided by y and y will cancel. We remain with negative 2b. All right, on the other part, x is also common, but take note here, this is a positive 3a, and here we've got a negative 3a. So to make this a positive, we are going to factor out negative x, so that minus 3ax minus and minus will cancel, x and x will cancel, you remain with positive. Remember, the issue is to make sure that these 2 brackets are the same. All right, on the other side, we factor out, okay, we divide plus and a minus, that's a minus, x and x will cancel. We remain with 2b if we divide. So the 2 brackets are the same. That means we are going to remain with 3a minus 2b, and on this other one, it is going to be y minus x like this. All right, so I want you to check something. On this answer that we have, we are supposed to also check with the other one that we are going to obtain on the other hand. So if we are to leave this in terms of y minus x like this, it means we are supposed to check also on the second one. So let's check what is going to happen on the other one so that we can confirm on how to represent your final answers in this case. All right, so the other one, we are given 3bx minus 3by. So this is 3by plus 4ax minus 4ay like this. Okay, so still applying the same issue that we did this previous part of grouping into 2. We are going to group into 2 in this case. So from the first part, 3b is common, as you can see here. 3b is common. So this is going to give us 3b. If we factor out 3b, we are going to divide. This is going to be positive x. If we divide by 3b here, they cancel. We remain with a negative y in this case. So our issue is to make sure that we have got positive x minus y from the other bracket. So we are going to factor out 4a, which is common. So if we factor out 4a and 4a will cancel. We remain with positive x. 4a and 4a cancels. We remain with negative y in this case. So the 2 brackets are the same. That means we are going to factor out the common bracket of x minus y, and we remain with 3b plus 4a in this case. All right. So from our factorization, if we are to check, we are supposed to determine the HCF and LCM of these two expressions, meaning to say, from these two brackets that we have, which are similar, these two brackets are similar. So when you are to determine the HCF and LCM, it is going to affect our answers. So we are supposed to write either this x minus y as y minus x, or to write y minus x as x minus y. So I can prefer to write this as x minus y. So how can I write this as x minus y? I simply factor out a negative. So the moment we factor out a negative like this on this one, this is going to be a positive x, and y is going to be a minus. And that means we've got 3a minus 2b like this. All right, so that means we can leave our final answers in this manner. Okay, so now let's check the question now on 2.12. Determine the HCF and LCM of the two expressions. All right, so remember that the HCF is supposed to be common throughout the given expressions that we are given in this case. So that's 2.12. So the HCF, now we can take the HCF as x minus y, because this is common, x minus y here, x minus y. But before we factored the negative, it was going to be difficult for us to have the HCF. All right, so this is going to be x minus y. That's our HCF in this case. All right, LCM, remember, it's a multiple, so it contains all the terms which are present, starting with the sign that we have out of the bracket, which is a minus. X minus y, we've got x minus y here. We do not repeat this bracket, we take it once. We've got 3a minus b, we take that one, 3a minus 2b. We've got 3b plus 4a, we take that one. So the LCM, it consists of all the terms that you are given from the two expressions. Every term must be present. All right, so that was our question 2.12. We move on to question 2.21, where we are given now to simplify each of the following algebraic fractions. All right, so that was the first question on 2.21. All right, so I'm not going to repeat this question. I'm just going to start by factorizing. Where there is a need for us to factorize, then we simplify. So as we know, guys, for you to simplify or to add or to subtract, it is best that you do factorize your denominators so that you can check for the LCM or the LCD in this case. All right. So here we have got 3m plus n squared. There's nothing that we can do in actual sense in the for this part here. But in the denominator, we can go back to our factorization. Still remember what we talked about previously on the issue of grouping of terms. So we can see that we have got 4 terms here, 1, 2, 3, 4. So by grouping, that's into 2, we check if there is anything that is common between these 2 terms. So m is common, we've got m and m. So if we factor out m in this case, this is going to remain as 3m squared divided by m. That's 3m plus mn squared divided by m. M and m will cancel. We remain with n squared. All right. From the 2 that is left here, what is common? N is common. So we can factor out plus n. So that means if n is common, if we divide 3mn divided by n, n and n will cancel. That's you remain with 3m. N to the exponent of 3 divided by n here. This is going to be n to the exponent of 2. So the 2 brackets are common. So we are going to factor out the common bracket of 3m plus n squared. We remain with m plus n. So this is going to be m plus n. All right. So that's a minus. We move on. In the numerator from this one, there's nothing that we can do. It's just going to remain as m minus 3n. Everything over. We factorize. So this one is a direct factorization since here the coefficient of m squared, it's a 1. So we can just have 2 brackets in terms of m. So that's m here, that's m. So remember that we are supposed to find factors of negative 6n squared. When you add, they will give us a negative n, So that's negative 3n and a positive 2n. If we multiply this, that's a negative 6n squared. If we add, that's a negative n. So that's minus 3n plus 2n. So you're going to have here minus 3n plus 2n in this case. All right, so that's what you're going to have. So from this part now, we have factorized, and we can see we do not have any bracket which is common, so we can just determine our LCM direct. All right, so remember that you're supposed to find the LCM of everything. So in this case, none of these brackets is the same. So you're going to have each bracket is going to be there. So it's 3m plus n squared into m plus n into m minus 3n into m plus 2n. Each and every bracket has to be present. All right. So let's divide back. Remember, it's your LCM divided to the denominator. So these two brackets will cancel, they are the same. So meaning to say we are going to remain with this bracket and also multiplied to the numerator. So meaning we are going to have this as 3m plus n squared in the numerator. Then remaining with these two brackets of m minus 3n into m plus 2n like this. All right. Minus, we do the same. If we divide our LCM to these two brackets in the denominator, these two will cancel, m minus these two will cancel, which means we remain with these two brackets. But they are being multiplied to the numerator, which is m minus 3n. All right, so you're going to have these two brackets, 3m plus n squared into m plus n like this. So this is what we are going to have at the end. All right, so if you are to check here, we're asking yourself, how am I going to simplify three brackets? Am I going to expand these three brackets that I'm having? Okay, this was not going to be like that. If you check, this question was tricky on this part to say m minus n this bracket, and also this bracket of n, m minus 3, and these two, they are the same. 3m plus n squared, 3m plus n squared, these two brackets are the same. So we can factor out these two brackets from the numerator. So that means if we are to factor out, we're going to have 3m plus n squared into m minus 3n, which are the common brackets that we have in this case. So if we factor out these two brackets here, we are going to, these two will divide. So we are going to remain with m plus 2n in this case. Minus, we factor out these two brackets from here, m minus 3n will cancel, 3m plus this one will cancel, we remain with m plus n. So this is what you're going to remain with. Everything over your numerator, the denominator in this case, which is 3m plus n squared into m plus n into m minus 3n into m plus 2n. Okay, also at this stage, something was going to happen here because now these two are factored out. So it's under multiplication. So we have the right now to divide these two brackets, which are the same, also this bracket and this bracket, which are the same, because it's out of the bracket. So these two can cancel. We have the right to do that, okay? So that means we can simplify our numerator now by expanding the negative, the brackets. Here there's a 1, so it's 1 times m, which is m, 1 times 2m, which is 2m, minus 1 times m, which is minus m, minus 1, this is a negative 1, so it's negative 1 times m, negative 1 times n, which is negative n. Everything over our LCM, which is now we are left with m plus m and m plus 2n. This is what we are left with now, m plus n into m plus 2n. So this was the very, very, very tricky part that we had. And if you could have conquered this, then you can see that, okay, I'm left with nothing at all. It's just a matter of simplification in this case. All right, this is 2n. This is 2n here. So we are going to have m minus m canceling to each other, then 2n minus n, this is same as 1n. So 2 minus 1, that's 1n, which is n, everything over m plus n into m plus 2n. And don't be tempted to cancel the n and the n here. These are expressions, these are terms, so these two cannot cancel. You can only cancel on a condition like a bracket and a bracket equivalent to each other. Then on that note, we can cancel the given brackets. All right, so that was the tricky part on this question if you have to check what we're given in this case. So we just have to revise as much as possible, especially for those ones who are to write their exams in August. Yeah, we can just revise because most of the times they do repeat questions which are challenging from one exam. They repeat those questions into another exam, especially a typical question like this one. All right, so let's check what we have on question 2.22 now. Again, on the simplification. But this is under multiplication. Everything is under multiplication. So there's no need for us to invert any fraction. Everything is under multiplication. All we need is to factorize. Then we can simplify further. All right. So from the first bracket, from the first one, x squared minus 8x plus 16. X here is the coefficient of x is 1. So you're going to have two brackets, x and x. Factors of 16, that when we add, they will give us a negative 8. In this case, that's a negative 4 and negative 4. So that's negative 4, negative 4. Everything over 6x plus 3. 3 is common, so you can factor out 3. 6x divided by 3, that's 2x. 3 divided by 3, which is a plus 1 in this case, all right? So times 4x squared minus 1, that's a difference of 2 squares, this one, because we can write 4 as 2 squared, x squared minus 1, we can write this as 1 squared. So as you can see, we've got our A and we've got our B. So the question is, if we are supposed to have A minus B, A plus B, so this is our A, this is our B, so we're going to have 2x minus 1 into 2x plus 1. So that's our difference of 2 squares. X minus 4, there's nothing that we can do here. Times 5x minus 5, we can factor 5 is common. So if we factor 5, this is going to be x minus 1. Everything over 1 here. So that means we've got two brackets. We can factorize this direct, x and x. Factors of 4, when we add, they will give us a negative 5. That's a negative 4 and a negative 1. If we multiply this, we obtain a positive 4. If we add, that's a negative 1. So that's negative 4, negative 1. All right. So since it's under multiplication, that means we can cancel whatever part that is applicable. Like x minus 4 in the denominator. I've got x minus 4 in the numerator. X minus 4 in the denominator, x minus 4 in the numerator. I've got 2x plus 1 here. I've got 2x plus 1 here. I've got x minus 1. I've got x minus 1. Do we have any part here? We no longer have anything. So on the numerator, we remain with 5 and 2x minus 1. So it is going to be 5 into 2x minus 1. In the denominators, we just remain with 3. So this is going to be over 3. All right, so that was going to be your final answer in this case. There's nothing that you can do in this case. You can't add, you can't simplify anything, you can't divide or do anything. So you're supposed to leave your answer like that. All right, so that was a question 2.22. All right, so let's check our question 3. Question 3, we are now given to solve for r in the equation. All right, so here we are given a typical equation whereby we can just simplify here 1 minus 1 over 9. All right, so we've got 3 to the exponent of r into 1 minus 1 over 9. This was going to give us 8 over 9 from our calculator, which is equal to 24. So since we are to calculate r in this case, we can divide by 8 over 9. It's a multiplication, so there's nothing that can this affect us. We can divide by 8 over 9, both sides. This can cancel. So we remain with 3 to the exponent of r, which is equal to 24 divided to 8 over 9. So this was going to give us a 27. So now at this stage, we can see that we have a certain consideration that we have in our exponents, whereby the exponent is unknown. We can make sure that these bases are the same. So if these two bases are the same, x to the exponent of a, if it is equal to x to the exponent of b, it simply means that a is equal to b. So now we have got 3 to the exponent of r, which is written as 27. 27 in terms of 3 is same as 3 to the exponent of 3. So the bases are the same here. It means the exponents are the same. So therefore, our R was going to be equal to 3. All right, so that was it for this question. On question 3.2, without using a calculator, show that. All right, so here we are asked to show that these two, they are equal. The logarithm, that's the logarithm of 32 in base of 16 is equal to 5/4. So how can we show that these two are actually the same? This is from our laws of, in fact, from our simplification, changing a log to an exponent. We know that from the logarithm of a in base of b, which is equal to c, this can be written as a, which is our number, is equal to the base of b to the exponent of c in this case. So that means in this case, we can change this to exponent form. That means our a is 32 in this case. So 32 is equal to the b to the base to the exponent of c. So the base b is 16. So this is 16 to the exponent of c, which is our c in this case, is the number of 5/4. So we are supposed to show that these two are equal. So how can we show that? Okay, we can simplify the right-hand side from our laws of exponents. Remember that x to the exponent of a over b is equivalent to the bth root of x to the exponent of a, everything to the exponent of a. So this is going to give us, let's see, 32 is equal to the 4th root of 16, which is our denominator, whatever that we obtain to the exponent of 5. Is that so? So 32 is equal to the 4th root of 16, that is a 2, and 2 to the exponent of 5, that's 32. And as we can see, these two, they are equal, which is what? Which is true. All right, so it's actually true that these two, they are equal. All right, so that is how we can simplify such typical questions. On question 3.3, use exponential laws to simplify the following. All right, so we are given in this case 2 to the exponent of n minus 2 to the exponent of n plus 2 over 2 to the exponent of n plus 3. Remember that we can separate these guys from our laws of exponents. That's x to the exponent of a times x to the exponent of b is the one that gives us the opportunity to add the exponents because we are multiplying the bases which are the same. So for you to, if you are given a condition like n plus 2 like this, before it was written as before it was written as a plus b, it was from a multiplication of two terms with the same base. And here our base is 2. So that means this whole question was supposed to be 2 to the exponent of n minus 2 to the exponent of n times 2 to the exponent of 2. This is before this was added together on the exponent. We were multiplying the bases which are the same. All right, everything over the same scenario that we have here, we are adding also. So that was 2 to the exponent of n times 2 to the exponent of 3. So we can see that 2 to the exponent of n is now common, that we can factor it out from the numerator. So we can factor out 2 to the exponent of n. If we divide these two, they cancel. That's a 1 minus 2 to the exponent of n cancels. We remain with the 2 to the exponent of 2. Everything over 2 to the exponent of n times 2 to the exponent of 3. So this gives us now the advantage to cancel these two because it's a multiplication that is again, so we can cancel these two. So we are remaining in the numerator with 1 minus 2 to the exponent of 2, which is same as 1 minus 4 over 2 to the exponent of 3, which is 8 So that was going to give us -3/8 in this case. All right. So that was the simplification of this exponent that we're given. On 3.4, write the following as a single logarithm. So remember that for you to have a single logarithm, it's an application of all the laws also. The bases are the same. We are in base of 2, base of 2, base of 2. So that's an advantage. But here, we've got the numbers that are multiplying the logarithms. Remember, if I am given p log m, I'm going to write this as the logarithm of m to the exponent of p. I raise this to be the exponent of a log. 3, I raise it to be an exponent. 4 to be an exponent. 5 to be an exponent. Ignore the signs that we are given here. Just ignore the signs that we are given. So that means we are going to have the logarithm of p to the exponent of 3 in base of 2 minus the logarithm of q to the exponent of 4, which is in base of 2, minus, we raise this to the exponent of 5, that's log r to the exponent of 5 in base of 2. All right, so if you do not want to mistake in this question, then simplify it step by step. All right, you can simplify the first two here, that you can factor out a negative in this case. All right, so that means we are going to have the logarithm of p to the exponent of 3 in base of 2 minus, if you factor out a negative here, this is going to be log q to the exponent of 4 in base of 2 plus, because it's negative, divide by negative, so it will be a positive now, the logarithm of r to the exponent of 5 in base of 2. All right, we know that if the bases are the same and we are adding the logarithms, the logarithm of x in base of a plus the logarithm of y in base of a is going to give us the logarithm of xy in base of a. We are going to multiply the numbers under the same base. So this is what is happening between these two. We are adding and the bases are the same. So we are going to multiply the terms that are under these logarithms. So this is going to be minus the logarithm of, we multiply q and r. So that's q to the exponent of 4, r to the exponent of 5 in the base of 2. So this is a single log of these two. We are supposed to obtain another single log again from these two now, combine them together. We are subtracting now, so we are going to oppose. If we are adding, we multiplied. So when we subtract, we are going to divide these terms. So this is going to be the logarithm of p to the exponent of 3, everything over q to the exponent of 4, r to the exponent of 5 in base of 2, like this. So that's a single logarithm that you're given in this case. All right, so that was our question 3.4, having a total of 4 marks. That's 15 marks on question 2. Question 4, we are now given that there is a cone that we have, which is of closed base, that has a base diameter of 30 centimeters and a slant height of 90 centimeters in this case. So take note, this is a closed cone that we have at the base. So we are given something of this nature here as our cone. So if you have to check, we are given the diameter, that is the base diameter of 30 centimeters. So from the diameter, we can determine the radius, which is diameter over 2. So that's 30 over 2 in this case, which is 15 centimeters. So we are given a radius of 15 centimeters in this case of the cone. So we do not have the perpendicular height. We are given the slant height, which is our L, which is the slant height of 90 centimeters in this case. So remember that this cone is from the slant height, the perpendicular height, and the radius, they form a right angle triangle. All right. So the question 4.11 was to calculate the perpendicular height of the cone in centimeters, which is this h that we are given in this case. All right. So like we say that if we are to check, this is giving us a right angle triangle. So you can apply our Pythagoras theorem to say that L, in this case, L squared is equivalent to h squared plus r squared. So that's h squared plus r squared. So to find h, we can substitute L, which is 90 squared, is equal to h, which is h squared plus r squared, that is 15 squared. So to find h, you can transpose 15 squared, that is going to be 90 squared, minus 15 squared, which is equal to h squared. So as you can see, to find h, we simply have to determine the square root because this is square. So h is going to be the square root of 90 squared minus 15 squared in this case. All right, so that is going to be the value of h, which is going to give us 88,741 centimeters to 3 decimal places. All right, so that was how we could have calculated the perpendicular height of this cone. On 4.12, the total surface area of the cone in square centimeters. So we need the total surface area. Take note, it's closed at the base. This cone is closed at the base. So that is going to be the total surface area. Remember that if it is closed at the base, our total surface area is going to be the area for the curved part, this curved part, which is pi RL plus the area at the base because it's closed, and at the base it's pi r squared. So that was going to be our cross-sectional area in this case. So that's pi RL, which is pi times the radius, which is 15, times our slant height, which is L, which is 90. So that's what you're going to have in this case, plus pi r squared, that is pi times the radius squared, and our radius in this case is 15. So that's 15 squared. All right, so this is going to give us the total surface area of the cone in square centimeters. So we're going to obtain 48,008,429. So that's going to be 0.008 in square centimeters. Okay, so that's 4,948,008 in square centimeters. All right, so that's your cross-sectional area, or the total surface area, sorry. Then the volume of the cone in cubic centimeters. So remember that volume, it's in cubic centimeters. But how do we calculate the volume of a cone? Also, we are given all these formulas in our formula sheet. All right, so remember the volume of a cone is given by a third base area times height, which is a third pi r squared h. So that is what you're going to use to calculate the area of a cone. So that's a third times pi times the radius squared, of which our radius is 15 squared, times the height. All right, take note, guys, the radius here, remember it's 15. Then the height is the one that we calculated here. We got our height here, which is 88,741. All right, so this is going to give us the volume of the cone. So that was going to be 20,909,1553. So it's going to be 1055. Okay, so it's going to be 106 if we round off to 3 decimal places, cubic centimeters. All right, so that is what we were given in this case. So this is going to give us the volume of the cone. All right, so let's check the other part of the question. On 4.2, we are given that a sphere is a volume. So we are given the volume of a sphere in this case, which is 900 cubic centimeters. And from this volume, we are now asked to calculate the radius of the sphere in centimeters. Okay, so we have got a volume of 900 cubic centimeters. How did we manage to calculate the volume? Remember that the volume of a sphere is equivalent to 4/3 from your formula sheet. That's 4/3 pi r cubed. So we can even substitute our information, or you can make r the subject in this case. All right, or you can just substitute your values, or you can make r the subject. So in this case, let's make r the subject. 3 times v, that's 3v is equal to 4 pi r cubed. If we cross multiply, divide by 4 pi both sides, divide by 4 pi both sides. So that means r cubed is equal to 3v over 4 pi. So to find r in this case, it is going to be the cube root of these both sides. All right, so that means our r is equal to the cube root of 3v over 4 pi. So that is going to be the cube root of 3 times v, which is your volume in this case of 900 over 4 pi. So this can give you the exact value of r. So therefore, our r in this case is going to be 5,89 in centimeters. So that's 5,89 989, not 989 in centimeters. All right, so that is what we could have done to calculate, or we can just substitute direct from the formula, then we calculate, we manipulate R from there. Still, it's one and the same thing. Then the total surface area, the surface area sort of the sphere in square centimeters. Remember that the surface area of a sphere is given by 4 pi R squared. So that means that is what you're going to apply in this case. So 4.2 surface area of a sphere, that's 4 pi R squared. So we have the radius now. So it's 4 times pi times the radius that we just got now, which is 5,989 squared. So this is going to be something like 450, so that's 450, 732 in square centimeters. Remember, that's area. Area is measured in square centimeters. Okay, so that is how you could have calculated this. All right. Then another part of the question 4.3 to mark the last part of question 4, having a total of 13 marks. Calculate the area enclosed by the x-axis, the y-axis. The line x is equal to 13 and the curve joining the points. Okay, so you're given the points that are being separated in between in this case. So if we are to check, remember that from your formula sheet, the area is given by the first ordinate. So this is going to be the first ordinate plus the last ordinate, everything over 2. All right. So whatever that you're going to have, you add the remaining ordinates. So plus sum of remaining ordinates. In this case, we've got the ones that are remaining times the distance that is between the ordinates. So we need the distance or the height, in this case, distance between ordinates. So in this case, if we are to check here, we were given the first ordinate, we can take it, the value of y here, that is 4, and here we've got 11. So that means it's going to be 4 plus 11, everything over 2, plus the sum of the remaining. So the remaining, we are now talking about values of y, which is we are remaining here with 6, 7, 10, 13. So we're going to add these ones. That's 6 plus 7 plus 10 plus 13, like this. All right. Then the values of x are the ones that gives us the distance between from the values of x. They are separated. How are they separated? Is from 0 to 5/2, from 5/2 to 5, from 5 to 50. So if you are to subtract 5/2 minus 0, that's a difference of 5/2. 5 minus 5/2, that's a difference of 5/2. 15/2 minus 5, that's a difference of 5/2. So this is the distance between the ordinates, which is of 5/2. All right, so that was going to give us the area in this case. So here we've got 4 plus 11, which is 15. Then if we divide by 2, that's going to be 7,5. Plus these other ordinates, if you add them together, that was going to give us 36 in this case. So this is going to be a 36. So whatever that you obtain here, we multiply to 5/2. So that's going to give us the area. So our area was going to be 108,75 square units. Remember, area measured in square units. So we can just leave our answer like that. All right, so that was our question. In this case, let's check the other part of the question, which is now on question number 5. So on question number 5, we were given the functions of f of x, which is this, and gy, which is also answer. Use the graph paper to draw both graph on the same set of x's clearly. Okay, so in this case, I'm not gonna draw these graphs like the way that it was supposed to be done. I'm just going to show you how we're supposed to have our graphs in this case. All right. So if you are to check, these were linear functions that you're given, gx and gy in this case. That's linear functions in this case. So on 5.11, we are given that our gx, which was the value of y, was equal to -1/4x, and other graph was of y is equal to minus half x minus 1. These are straight lines. So for you to draw a straight line, you can just draw your table of values that you are going to use to determine the values of y. You've got the values of x that we use to determine the value of y. Just 3 values, they are enough in this case. All right. So x, y here. So let's say I choose points like x, it's -4, x, it's a 0, x is a 4. So I'm going to substitute in x here. When x is -4, that's -1/4 times -4, which is a +1. When x is 0, that's going to be a 0. When x is 4, -1/4 times 4, that's -1. You can even use a calculator. So this first, you are just substituting. So using the same way, you can even do this for the graph of y is equal to minus half x minus 1. So we've got x and y here, 3 points. They are actually enough. -2, 0, and 2. We substitute our points. When x is -2, this was going to give us 0, -1. This was going to give us a -2. So what am I trying to say? These points that we have in this case are the ones that you are going to use on your graph, meaning to say, on your graph, you're going to mark these points that you're given. In this case, let's say you were having your points in this case. This is our x, this is our y, like this. We have got up to 4. So we can just say 1, 2, 3, 4, -1, -2, -3, -4, -1, -2, -3, -4, 1, 2, 3, 4. So you mark your points, -4 versus 1, that's -4 versus 1. You mark your point 0, 0, that's here. 4 versus -1, that's it. So you can even draw your line from these points that you have marked. You can draw your line like that, okay? Making sure that your line passes through the points that you have indicated in this case, all right? The same thing was happening on this line, -2 versus 0, that's somewhere here. 0 versus -1, somewhere here. Then we've got 2 versus -2, somewhere here. So if we are to join this line, it was going to be something of this nature. All right, so as for you guys, you are having a nicer graph than the one that I'm having. Okay, this is not giving me exactly what I want. Is because of the point that I'm having. But as for you, you're going to have a smooth, very, it's a straight line, definitely, because you're using your ruler in this case. So this is how you're going to have, you mark your points, then they will meet at a certain point like this way. That's according to your graph. All right. So I want you guys to have a better graph. Then read from the graph in question 5.11, the coordinates of point where f of x is equal to gx, where these two, they are equal. So we are saying the two graphs, they are equal where at the point of intersection, which is here. So you take the value of x, you also take the value of y, which corresponds at that point. All right. So according to me, this point of intersection was at -4, at -4, 1. X was at -4, y is y. It's only that on this graph, it's not clear. It's not clear because this is just a sketch, but you're supposed to draw an accurate graph. As for me, here, I'm not having that graph paper so that I can actually show you the points, but that's the major points that you're supposed to have on your graph. All right. The same thing that is happening on question 5.2, we are given the function of f of x. So the function of y, which is equal to 3 sine x from 0 to 180, and y is equal to 2. So you're asked now to draw the graphs, okay? So still we are using the same thing, but here we are asked to use the broken lines for the graph of y is equal to 3/2. All right, so for the graph of y is equal to 3 sine, we are still having the same concept just like that one. We can still have our table, that's 5.2. Y is equal to 3 sine x. We are asked that our values, they are supposed to be taken from what? From 0 to 180. So this is the interval that we have where x is greater or equal to 0, less or equal to 180 degrees. So we can just have our table in this case. Remember, the graph of sine is best separated by 90 degrees. That's the best way to separate the graph of sine and cos by 90 degrees. So this is going to be 0, 90 degrees, then 180 degrees. All right. So this is where we are taking from 0 to 90. Okay. So 3 sine simply means 3 sine 0 like this, which is going to give us a 0. We move on. 3 sine 90, that is going to give us a 3. Then 3 cos 180, that's a 0. All right. So meaning to say our graph of sine was going to be like this in this case if we were to draw. So in this case, like I said, here is just a sketch that I am showing you. So it was going to be taken only from 0 to 3. So this is our 0 here. This is, let's say, 1, 2, and 3. That's -1, -2, -3. That's your y-axis. We've got 0 degrees here, 90 degrees, and 180 degrees. So 0 is versus 0. So this one, that's 0 versus 0 at this point. 90 versus 3. So it's 90 versus 3 at this point. 180 versus 0, that's 180 versus 0 like this. So your curve was just going to be like this, guys, just like this. This is what you're going to have. It was not going to be a complete sine. Remember, our normal sine wave is supposed to be like this, but here it was just from 0 to 180. That's what you're given, where the maximum value corresponds at 3, where x is at 90 degrees. All right, so that's the graph of y is equal to 3 sine x. All right, then what about the graph of y is equal to 3 over 2? We are also given here y is equal to 3 over 2. As a decimal, 3 over 2 is same as 1,5. So we need the graph where y is at 1,5. So 1,5, that's in between 1 and 2 in the y-axis. So this one is a straight line. But remember, we are asked to draw this line as a broken line in this case like this. All right. So that's y is equal to 3 over 2. That's what your graph was going to look like. All right. So the question now is from these graphs that we have drawn. All right. From these two graphs, read from the graphs in question 5.22 the values of x for which the both graphs intersect each other. All right, we need the values of x, which is the angle where these two graphs intersect. So if you were to take these values properly from your graph at this point of 1,5, this point here was going to correspond with 30 degrees, and this point here was going to correspond with 150 degrees. So our x is at 30 degrees, or our x is at 150 degrees. These were the x coordinate, or the values of x at the point of intersection of the two graphs, the sine graph and the graph of y, which is a straight line. All right, so that was just 1 mark for that. On question 5.3, the sketch below represents the graph of y is equal to x squared minus x minus 20 and y is equal to minus 14 drawn on the same axis. So these are the two graphs that we have. Remember, okay, this is your x-axis and this is your y-axis in this case. All right, so this is at 0.0. All right, sorry for that. So from this part that we are given on first part of the question, which is 5.31, it was to determine the coordinates of A and B. A and B. Okay, what is A representing and what is B? These are the values of X in the x-axis. That is the x-intercepts, where we know that in the x-axis, y is equal to 0. So we can take advantage of that to say A and B are on the x-axis. So that means we are calculating the x-intercepts where y is equal to 0 in this case. All right, so this is going to be the x-intercepts. All right, so let's have this as 5.3. So from our equation of y, which is equal to x squared minus x minus 20, we are saying at that point, y will be equal to 0. So let's see what we have if y is equal to 0. We are just solving this 0 here. So x squared minus x minus 20 will be equal to 0. That's a normal quadratic equation. So we can solve this by factorization. Since the coefficient of x squared, it's a 1, we can factorize this. That's x here, x. Factors of negative 20. If we add, we get a negative 1 in this case. That's negative 5 and 4. So we are going to have negative 5, negative 4. So each bracket must be equal to 0. X minus 5 must be equal to 0, or x minus 4 must be equal to 0. X plus 4, sorry. So that means x is equal to a positive 5, or x is equal to a negative 4. So which one is our A? Which one is our B? All right, we check according to the points that we have. A is on the left side of the Cartesian plane. So that means it's a negative. B, it's a positive. So here we have got negative 4. That's for A. 5 is for B. So our A in this case is negative 4, 0. And our B is 5, 0. Remember, this is x coordinate where y is equal to 0. So our point is going to be minus 4, 0 and 5, 0 for A and B. All right, so at this point A, we've got negative 4. And at this point, we have got a positive 5 in this case. All right, so the other part of the question now was to calculate or to determine the coordinates of E and F. All right, where do we have our E and where do we have our F? Okay, E and F, if you have to check here, that's a point of intersection here, E and F. These are points of intersection where y is equal to minus 14 is intersecting with the graph of y is equal to minus x minus 20. So all we need is to calculate the point of intersection. All right. So how do you calculate the point of intersection? Remember that these two graphs, they will be equal. So y will be equal to y. So given the y, which is equal to x squared minus x minus 20, and the graph of y, which is equal to minus 14. These two graphs, they intersect at each point. So that means they will be equal. So we can calculate the values of x, since at that point we know that y is at minus 14. So already the value of y is there. So all we need is to calculate the values of x, which corresponds to these values of y that we are given. So it's a quadratic equation. We can transpose x squared minus x transpose minus 14 to this side is going to be a plus 14. So minus 20 plus 14 minus 6 is equal to 0. All right, so you can factorize here. The coefficient of x squared is 1. So you're going to have two brackets. That's our x and our x here. Factors of negative 6, if we add, we obtain a negative 1. That's negative 3 and 2. So we are going to have negative 3, a plus 2. So equate to one of the brackets just like previously. X is going to be 3 or x is going to be minus 2. So which one is our negative 3? Which one is a positive 3? So if you are to check on our points here, E is the one that is on the negative side. So that's a negative. EF is on the positive side. So that means, therefore, our E in this case is going to be a negative 2. So therefore, our E is going to be at negative 2. But remember that the value of y is at negative 14. So that's minus 14. And our F is still at minus 14 for y, but x is at 3, which is a positive. So it's 3 minus 14. So that is how we could have calculated or determined the point E and F. It was a matter of play around with the graph question. All right, on question 5.33, we are now given now to calculate the y value of C. Okay, the y value of C here. C is the y-intercept, and as we know, the y-intercept, it's on a condition where x is equal to 0. So we can substitute x is equal to 0 into our normal quadratic equation. If x is equal to 0, that means y is at minus 20. So that point is going to be at negative 20. Okay, 5.34, determine the coordinates of D. All right, in this case, this question was not properly given. Why am I saying so? We do not assume that this point D is a turning point if we are not given. All right. But in this case, it was actually a turning point. They are giving us this D is a turning point, but we do not assume. So take note about that. You don't assume that this is a turning point. No, 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 no. All right. So this D is representing a turning point where we know that a turning point X is equal to minus B over 2A. So we can use this concept to say that at turning point, so this is 5.34. Remember that our equation was minus x squared, sorry, that's x is equal to plus x squared minus x minus 20. So at any turning point that we have of a quadratic, x is equal to minus b over 2a. So this is 1, this is -1. So we've got our a and our b. So that means at our turning point, x is minus b here, which is -1 over 2 times a, which is the coefficient of x squared, which is 1. So that's negative, negative. That's a positive 1 over 2. So we are having the value of x at turning point is 1 over 2. So you're supposed to determine the value of y by substituting the value of x, which is 1 over 2, in place of x here. So it is going to be 1 over 2 squared minus 1 over 2 minus 20. So that will give us the value of y, which was a negative 81 over 4. So therefore, that was our point D, which is the turning point at x, which is 1 over 2, and at a point of y, which is minus 81 over 4 in this case. All right. So that is how we could have calculated the value of D, which was a turning point. But like I said, the question was not properly given. So I just hope we understand what I'm trying to say. On question 6.1, we are now given to convert 18 degrees 24 minutes to degrees. Hence, calculate the value of sine 18 degrees 24 minutes. So guys, remember that a degree is equal to 60 minutes. So if I'm given 24 minutes, I divide by 60. That's 24 minutes is equal to how many degrees? All right, because the question is just 2 degrees only. So we convert, that's 24 over 60 times a degree. So this is going to give us 0.4 degrees. So we add to 18 degrees. So our answer is going to be 18 plus 0.4, which is 18.4 degrees. All right. But hence now calculate sine. So it is going to be sine 18 degrees 24 minutes is same as 18.4 degrees. So you determine the sine of 18.4 degrees from your calculator. That was going to give you 0.3156, which is 0.316 if you round off to 3 decimal places. All right, so that was it from this one. In the diagram below, fig 2, the hypotenuse OB is equal to 1. So we are given that the hypotenuse of this diagram from O to B is equivalent to 1. And we are given the point B minus xy, meaning to say from O to this point, that's minus x. This is the x-axis. We are in the negative region. Y is above. It's a positive like this. All right. So the question is now copy and complete the table below. So we are given a certain example that we have from tan, that is minus y of where is this coming from? It's actually from our ratios. Remember, from our soccer tower like this. Tan is opposite over adjacent. So according to theta here, this is the opposite adjacent. So it's y over minus x, which is same as minus y over x. So this is what we are simply doing here. So we are given here sine theta. So remember, sine is opposite over hypotenuse. So we are supposed to use opposite over hypotenuse concept. So sine opposite, that's y. Hypotenuse, it's 1. So this is the opposite according to theta. This is the adjacent according to theta. This is the hypotenuse. So opposite over hypotenuse, that is going to give us y over 1. We move on to cos. Cos, that's adjacent over hypotenuse. So adjacent, which is minus x, hypotenuse is 1. So it's going to be minus x over 1. Cot theta, remember that cot is equivalent to 1 over tan of theta. So we have got tan theta here, which is y over, so 1 over, that's the inverse, you invert this, so it's going to be minus x over y sec theta. Remember that sec, it's 1 over cos, so this is 1 over cos theta, so we also invert cos theta, it's minus x over 1, so we invert is going to be minus 1 over x. Same with cosec, 1 over sine, so it's going to be 1 over y. In this case, you invert. All right, so this is what you are required to do from this one, just from your table. All right, it's complete. You're supposed to copy that table and to complete it. All right, given triangle ABC, calculate BC in meters from B to C. So this we can use Pythagoras since we are given two sides of the triangle, which is a right angle triangle. And we know that our Pythagoras says that h squared is equal to a squared plus b squared, which is the hypotenuse squared of 100 squared is equal to the 20 squared plus the other side, which is BC squared. All right, so you can calculate from there, BC transpose. This is going to be 100 squared minus 20 squared, which is equal to BC squared. So to find BC, that's a square root here. So BC is equal to the square root of 100 squared minus 20 squared. So that was going to give us the value of BC, and our BC to 3 decimal places, that's 97,9795. So it was going to be 980, okay, in meters. All right, so that's our BC. 6.32, the value of angle A. So take note, this is our A, so we need this angle here at point A. So how can we determine the angle A? We can take note of the information that we are given. According to this angle A, we have got 20 meters here, which is the adjacent. The 100 meters is going to be the hypotenuse. According to this angle here, I'm referring to this angle A. So that means we can use the ratio of cos to say that the ratio of cos of theta states that is adjacent over the hypotenuse. So that I can substitute now to say the cos of angle A, which is the cos of the angle that I'm supposed to calculate A, is equal to the adjacent, which is 20, over the hypotenuse, which is 100. So we can calculate our A here from arc cos of the answer. So that is arc cos 20 over 100 in this case. All right. So what are you going to obtain from this case? Arc cos of 10 over 100 is going to be 78,463 degrees to 3 decimal places like that. Okay. Or you could have used even sign, since we have BC here as 97, 98. We can even use opposite over hypotenuse, whatever that you want, you can still find that one. Okay, then to calculate angle C, since we now have the angle at A, we can use this angle now to calculate angle C. Remember that angles in a triangle, they add up to 180 degrees. So to find the angle at C, we are going to subtract everything from 180. That's 78,463 degrees at A, and the 90 degrees that we are given. This is a right angle triangle. There's also an angle there of 90 degrees. So you can subtract these two from 180 degrees. This is going to give us angle C, which is going to be 11,537 degrees. All right, so that is going to be our angle C in this case. All right, so that was our question 6.33. Having just 1 mark for that one, okay, just because it was a direct one. All right, on 6.4, convert 1,2 radians to degrees and minutes. So remember that we can first convert this to degrees, since we know that pi radians is equivalent to 180 degrees. So you can convert 1,2 radians to degrees first. 1,2 is equivalent to how many degrees? So that's 1,2 over pi times 180 degrees. All right. So in degrees, this is going to give us 68,75 755 like that in degrees. So, but the question needs us to convert to degrees and minutes. So we are going to take the whole number here to represent the full number of degrees, which is 68 degrees. Then the remaining part, we convert it to minutes. So how do you convert to minutes? Remember what I said, 1 degree is equivalent to 60 minutes. So if we are given this decimal of 0.775 degrees, we multiply by 60. And this is going to give us 45.3 and so on, which is 45 minutes. So it was going to be 68 degrees, 45 minutes. All right, on 6.5, we are now given in this case that there is a sector of a circle of angle 0.38 radians at the center and of the arc length having 45 centimeters. So this is the arc length that you are given in this case, which is S. It's 4.7 centimeters, and you are given the angle here of 0.48 in radians. So the question on 6.41 is to calculate the radius of the sector in centimeters. So remember, if I am given arc length, I can be able to calculate the radius since arc length. So this is 6.51. Remember, arc length is equal to r theta if r is in radians. If theta is in radians, so to find r divided by theta. So that means radius is equal to arc length of 4.7 over theta in radians, which is 0.48. So this is going to give us the value of r in this case in centimeters. So our r is going to be 9.79166 and so forth, which is going to be 9.792 centimeters. So we have got the radius in this case. Then we move on to 6.52, the area of the sector in square centimeters. So that's 6.52. So remember that area is equivalent to half r squared theta, provided that theta is in radians. So our area is going to be half times r, which is the radius, 9.792 squared, times the theta, which is the angle of the sector in radians, which is 0.48. So we can multiply by 0.48. All right, so that was going to give us the area of this sector, which was going to be 23.01198, which is 23.012. All right, in square centimeters. All right, so that was going to be the area in this case. All right, on question 6.6, we are now given that in this case, all right, let me just remove this. We are given in question 6.6 that given a wheel turns at 66 revolutions per second. So we're given n, which is 66 revs per second in this case. If the wheel has a diameter, then we are given the diameter of the wheel in millimeters, which is 93 millimeters. 6.61, we're asked to calculate the peripheral velocity of the wheel in meters per second, which means we are supposed to calculate V. So 6.61, remember that V is equivalent to pi dn, which is measured in revs per second, and this is supposed to be in meters, the diameter. So in this case, we can use this formula, but make sure that your diameter is converted to meters. So we know that milli means times 10 to the exponent of -3 times n is already in revs per second, which is 66. So this one we can just multiply direct. So this was going to give us 19.23. That's 19.283, yes, in meters per second. So we've got our peripheral velocity. Then on 6.62, the angular velocity of the wheel, which is omega in this case. So remember that the angular velocity is omega, and omega is equivalent to 2 pi n, where n is in revs per second. So omega is 2 pi. All right, so this is going to be 2 pi times n, of which our n in revs per second is 66. So omega is going to be 414. So that's 414,602. And so this is going to 6902. So it's going to be 690, or just 69 rad per second. So remember that the angular velocity is measured in what? In rad per second. All right. So that was the question paper, guys. March 2023 exams from Meson African Motives, Mathematics N2. having a total in this case of 100 marks. So yes, that's what we had. So for those who are writing in August, let's continue to revise. We still have time to prepare for those exams that we have in advance. So let's prepare with the time that is remaining for now.